All right, this is lesson 4.2, parallel lines and transversals. So in the last lesson, we started talking about the relationships between lines, two lines, or the relationships between different angles, and what those are. Specifically for the angles, we looked at these four different types of relationships: corresponding angles, alternate interior angles, alternate exterior angles, and consecutive interior angles. And so it's important to remember what each of those are, and how the different positions of the angles, what each of those are for the different positions. So remember, we're talking about lines when they're angles that are formed when two lines are cut by a transversal. Remember that transversal is just the line that is crossing those two lines. So this line T here in each of these images is the transversal. And the numbers are indicating which angles we're particularly talking about. So 2 and 6 here are corresponding angles, 4 and 5 are alternate interior, 1 and 8 are alternate exterior, and 3 and 5 are consecutive interior. So those are the four different angle types angle relationship types that we looked at last time. In this lesson, we're going to look at those angle types again, but specifically when we have parallel lines that are cut by a transversal. Because as you can see in these images, these lines are not parallel. They're just two lines cut by a transversal. If we specifically look at parallel lines cut by a transversal, like in these four images, that gives us a little bit more information. It actually gets a little bit more interesting with what we can determine about that figure and about those angles. So in this first one here, A, corresponding angles, we're looking at 1 and 5. Those are the corresponding angles in the corresponding position. And we have two parallel lines here. Again, remember these little arrows on the lines indicate that those two lines are parallel to each other, are cut by this transversal here that's cutting through. And what we learn in this lesson is that corresponding angles are actually congruent to each other. So if we have two parallel lines cut by a transversal, the corresponding angles formed by that transversal cutting over those two lines are congruent to each other. The corresponding angles are congruent. For alternate interior angles, it's the same. If we have two parallel lines cut by a transversal, the alternate interior angles that are formed by that are also congruent. Alternate exterior angles are congruent as well. In consecutive interior angles, there's a relationship there, but it's different. Consecutive interior angles here in this fourth picture, 2 and 5, they are supplementary to each other. It means their measurements add up to 180 degrees. So those are the four angle types, relationship types we've looked at, and now we're identifying that when we have two parallel lines cut by a transversal, we know a little bit more about those angles. And this is particularly for parallel lines cut by a transversal. If it's just two lines, they're not parallel, then we don't know for sure exactly what their measurements are. But because it has been proven with these theorems, because it's been proven that if we have two parallel lines cut by a transversal, then the corresponding angles are congruent, the alternate interior angles are congruent, and the alternate exterior angles are congruent. And remember, congruent means they have the same measurement. And then the consecutive interior angles are supplementary to each other. You don't need to memorize all these theorems, but the more that you work with it, you should be able to start recognizing, oh, I've got corresponding angles here, they're congruent to each other. Oh, I've got alternate interior angles, they're congruent to each other. Oh, these consecutive interior, they're supplementary. And so that's what the theorems are saying. So if we can identify we have parallel lines cut by transversal, then we can identify the angle measurements. Like in this example here, if we have this figure, two parallel lines cut by transversal, if we know one of the angle measurements is 120 degrees, then I can start finding the other angles. If this is 120 degrees, then its corresponding angle 5 is also going to be 120 degrees. And its alternate exterior 8 is going to be 120 degrees. And its vertical angle here 4 is going to be 120 degrees, because that's also the vertical angles are also congruent that we've talked about before. And then I could even find 2 based off of consecutive interior and based off of linear pairs. So we know a lot of information about angles, and now we're trying to put that all together when we've got these parallel lines cut by a transversal. So let's look at an example together and solve one. All right, let's look at a couple examples. Let's look at number 3 on page 9 in your notes. The directions say to use the properties of parallel lines to solve these following problems, to find the value of x. So in this figure here with number 3, we first want to take stock of what do we have here, take notice of what's going on. We have two parallel lines cut by a transversal. Okay? We're told that this angle is 115 degrees. This angle down here is x plus 5, and we're looking for what x is. And they give us a hint that this angle 4, which we're calling angle 4, is going to be involved in some way. And so you might ask yourself, how do I start this? How do I know where to start? Well, look at what's given to you and then kind of build off from there. So if I know this angle is 115, I might ask myself the question, how is this angle related to angle 4? Okay, how are those two angles related to each other? If you remember, when you have two straight lines like this, like these two lines, the angles across from each other, formed by opposite rays, are congruent to each other. Those are called vertical angles, and they're congruent to each other. So we can say the measure of angle 4 is equal to 115 degrees, and that's because those two angles are vertical angles. Okay? And I'm going to write my kind of reasons and my thinking off to the side so you can remember what we did and how we know it to be true. So the measure of angle 4 and the 115 degree angle are vertical angles, and so they're going to be equal to each other because vertical angles are congruent, and so the measurements are equal to each other. And then I'm going to ask myself the question, okay, what's the relationship between angle 4 and the x plus 5 degrees angle, and that angle? Well, I notice that those are consecutive interior angles. Okay, that's why you want to have a good visual or have it in front of you on your notes. Hey, what's the consecutive interior, what's corresponding, what's alternate interior, and so on. So these are consecutive interior angles. And because we have parallel lines cut by a transversal, we know consecutive interior angles are supplementary. So the measure of angle 4 plus the x plus 5 degrees angle should be equal to 18 degrees, 180 degrees. Okay. And that's because those are consecutive interior angles. Okay, those are consecutive interior angles in between parallel lines cut by transversal. And I'm still trying to solve for x here. Because I started by saying the measure of angle 4 is equal to 115 degrees, I can substitute in 115 for the measure of angle 4. So that would be 115 plus x plus 5 is equal to 180. Remember, if you're solving for x, you need to set up some sort of equation. And so that's what I did there. Is I set up this equation and then I substituted in 115. Now I'm solving for x. 120 plus x is equal to 180. Subtract 120 from both sides, x is equal to 60. And that's my answer. So I observed what was going on in the figure, and the relationships between the different angles, and then used my new knowledge about these properties of parallel lines, where if I have consecutive interior angles, then they are supplementary, and then I solved the equation. All right, let's look at the next example, number 4. Again, I'm going to do the same thing. First, observe what I have. I have two parallel lines cut by a transversal. I know this angle is 136 degrees. This angle is 7x plus 9 degrees, solving for x, and they're giving me a hint that angle 1 is involved in some way. And so I'm going to just kind of build off of what's given to me. If this angle is 136 degrees, what is its relationship to that angle 1? Okay, what is their relationship? If you remember from our first unit, and we've kind of reviewed it a little bit this unit, when you have a straight line here and the angles have a common ray in the middle, these two angles form a linear pair. And these two angles form a linear pair, and angles that form a linear pair are supplementary. And so their measurements add up to 180 degrees. That's because they're a linear pair. Okay, they're supplementary because they're a linear pair. And then I could solve for measure of angle 1. and there are a couple different ways to solve this this problem, so you might find them. If I subtract 136 from both sides, that's 44. And the measure of angle 1 is equal to 44. All right, so that gets me part of the way there, but I need to still figure out what x is. So I want to figure out what's the relationship between 136 and the 7x plus 9. Well, I currently don't know any, we don't have any knowledge about relationships between those types of angles. That's not corresponding, alternate interior, or exterior, or consecutive interior. But I do know that angle 1 and 7x plus 9 do have a relationship. Okay, they are alternate exterior angles. So 1 here and this angle down here, 7x plus 9, are alternate exterior angles, and alternate exterior angles are congruent. Okay. So that means their measurements are the same. So the measure of angle 1 is equal to 7x plus 9, and that's because they are alternate exterior. And those are alternate exterior. And so they're going to be congruent, so their measurements are equal. So I still haven't solved x, but I know that the measure of angle 1 is equal to 7x plus 9, and the measure of angle 1 is equal to 44. And if you remember what the transitive property says, that if two things are equal to the same thing, then they're equal to each other. Since both of those are equal to the measure of angle 1, I can say 7x plus 9 is equal to 44. 7x plus 9 is equal to 44. Now I can solve for x. I'll subtract 9 from both sides, so it's 7x equals 35. I subtracted 9 from both sides. Divide by 7. X is equal to 5. So again, looking at your figure, identify the relationships between the different angles, okay, and just try to figure out what do I know. Okay, I started with figuring out, okay, these angles form a linear pair, so they add up to 180. That helped me figure out the measure of angle 1 is equal to. And then I looked at the relationship between 1 and 7x plus 9. That told me that measure of angle 1 is equal to 7x plus 9. Used transitive property that I was able to set these equal to each other, and then solve for x.